to say 38 of them are really infected. Right? It has only 95% accuracy.
How did you get 38?
38 is 40 times 95, 12.95. There's 95% accuracy, so if you run on all the 40 infected computers, which you don't know which of those 40, but when you solve this problem, you kind of write it down like this, right? So 40 times 95% is 38 computers. So you can really say those 38 computers infected. Now, when you run this on the 3960 computers, it has what? 95% again accuracy, which means it can say 5% of them as infected when they are not really infected. Right? So, what is 3960 times 5? That should be 198. So 198 computers are not infected, but it raises a flag that they are infected.
Okay.
Okay? And these 38 are infected, really infected. They are really infected. They are not infected, but it raises a flag as infected. So you want to find out what is the probability that your computer in which it raises a flag as infected is really one of the infected computers. Right? So what you will do? You want to find what's the probability that your computer is really infected. Right? So if it is really infected, it has to be what? And it raises a flag. So when you run the antivirus scanner on your computer, it raises a flag. Right? So it raises a flag totally on how many computers? On this 38 computers as well as this 198 computers, right? So it raises a flag on this 198 plus 38 computers, right? And your computer is also one among those computers for which it raises a flag. You want to find out to which category your computer belongs to, whether it is really infected or it is not infected, but the antivirus scanner just simply raises a flag. Okay? So the probability that your computer is really infected is going to be what? 38 over
198.
198 plus 38. Because it does raise a flag on your computer, so you want to see what is the chance, the probability that it is really infected. So that's why it's 38 over 198 plus 38. Okay? Is that clear? So the same kind of problem, just with some number change. Or I may say, what's the probability that is not infected? So it's 1 minus of it. So if you know probability, you should be able to do that, right? Okay. So the other thing should be directly from the slides to go through it. This is also directly from the slides. One question which I don't want to say, but I don't know if I don't say it, may not be able to answer it. Look at this number 4 in ITsec. We saw previous class also I went to this tunnel mode and transport mode and all those things, right? So you have here 4 sites. Sites means like networks. Where you have 10 computers, I believe, in each of them. Right? So you have 10 computers here, 10 computers here, 10 computers here. And when you run this IPsec security when you run IPsec, you have to establish security association in both directions, right? So what you want to find out is if this whole setup runs in tunnel mode, how many security associations would you establish?
4. No, it has to be both ways. 8.
How many security associations with any pair of sites? Like if I want to communicate from this side to this side, or from this side to this side, or from this side to this side?
16.
Not very close, but not really. So which means like simple, like you want to communicate from here to here, right?
2. 4 times 4, 16.
Right, so then it also need to be bidirectional or unidirectional, so you want to set in both directions. Okay, so how much it is? 6, right? And you already covered 2 of them here, right? So which means you have to just establish 2 more here, and then 2 more this way.
Okay, 10.
Right, 10. And this guy already has with this, so it has to do only with this.
12.
So 12. So how do you get in general? If you want, say, it's just like what? In the algorithm plan or anything, you say how many wires you need to connect n computers, right? So if you have 4 sides here, how many wires how many associations? Just consider one way. Okay? So one way is going to be what? 4 times 4 minus 1 over 2, right? So you need this, and this, right? So, but this is going to be just one way, so if you want both directions, unidirectional, right? You want both directions, so it's going to be 4 times 4 minus 1. So that's going to be 12. Is that clear? So if we have 6 sides, it will be 6 times 6 minus 1, so that's going to be 30. So if I change the numbers, it should be
You said 2 ways is 4 times.
if you have like, if the association is bidirectional,
Yeah.
because if you have set up one association and you can communicate in both directions, right?
Yeah.
How many associations you need? You need only this much. 4 times 4 minus 1 over 2.
Okay. Which is
But since the associations are only unidirectional, you need to establish an explicit association in each direction. Right?
Yeah.
So that's why every link has to be basically replicated, like kind of one in each direction.
yeah.
So that's why it is this times 2. Okay? So if you have a wire, if 2 entities can communicate using just one single wire, you just need one wire. But if the wire can transfer information only in one direction, you need 2 wires connecting them, right? One in each direction. So same thing. Is that clear? If 2 people, 4 people I mean, so the 4 of them, so this guy can connect with 3 of them, right? If the connection or association is bidirectional, we just need 3 associations, right? So information can flow in both directions. On the other hand, if information can flow in only one direction, what you're supposed to do? You're required to set up like 3 associations going like this, and then 3 more associations coming out like this. Right? So that's why it is. So what you do, the way you solve is find as if it is bidirectional. So if it's bidirectional, you will get 4 times 4 minus 1 over 2. This is the total number of associations if it's bidirectional. But since it is not bidirectional and each association can be in only one direction, you have to establish twice that number of associations. So that's why it is 4 times 4 minus 1 over 2, whole thing multiplied by 2. You have to establish twice that number of associations. Is that clear? Okay. So this is in tunnel mode. So if you want to operate this in transport mode, you have to use this number also. So you have 4 sides, you have 10 computers in each of them, right? So totally how many computers do you have? 40 computers, right? And I want to establish associations between any 2 pair of computers. Okay? So how many associations we need?
40 times 2. 40 times 2.
40 times
2.
2.
40 times 4.
40 times what?
39
39.
times 2 over 2. Yeah, so 40 times 39 is
It's the same thing?
Yeah. Yeah.
Same thing, but you have to consider the number of computers in each site. Right? So that's just to test whether you understood transport mode and tunnel mode, because transport mode means you are communicating directly from the computer to the other computer using IP-SIC association. If you use tunnel mode, what it means? All the 10 computers send their packet to the gateway, and the gateways have the associations. right? So that's why with the tunnel mode you need few associations, security associations, whereas with the transport mode you need a security association between every pair of computers.
So the 4 times 4 minus 1 is transport,
It's tunnel.
tunnel. And you're doing transport now.
Transport is 40 times 39.
So it's the same thing.
It's the same thing, but
Same formula, but
same formula,
different
but
numbers.
they have to apply depending on the number of computers in each site and the number of sites.
Okay.
And transport mode also has bi-direction and single, and not.
It is unidirection also, so you have to establish in each direction.
This is in times 2.
So it is as simple as this, but the thing is you have to know, so you can consider this as a formula, but of course this is times 2, so it simplifies to n times n minus 1. So what is this n? Depends on whether it's transport mode or tunnel mode. If it's transport mode, it's basically the n is the number of computers per site times the number of sites. So you have 10 computers per site and there are 4 sites, so 40 computers. So 40 times 39. So using tunnel mode, you just need association between the sites. So you have 4 sites, so it's 4 times 3. Okay? Anybody would have done this if I did explain this now? So, okay, so.
It was one of the ones that had a question mark.
Alright, so everything else I believe pretty straightforward. We went to the WAP gap and all those things. And then, what was the other chapter? Malware, this, okay, biometric is not there, it's only 3 chapters. Okay? Good?
Good.
So Wednesday at 6, not at 7:30. The class starts at 7:30, but the